Hello friends, today in contour milling we will see adaptive milling. Adaptive milling is a roughing operation and we call it high speed machining, and we use this adaptive milling for complex shape, but here the tool axis is fixed. We need part and blank both with workpiece geometry to define this adaptive roughing. Adaptive milling is very good choice for hard material with higher productivity with a longer tool life. In adaptive milling, we use smaller step over and depth of cut may be 20% of tool diameter, or according to the flute length you can define according to the height material hardness. So let's say this. For adaptive milling, we need solid carbide tool. So first of all, I am going to define a tool. Say here I have a tool D8 8 dia tool. So again I am going to use same tool and I am deleting the previous one. Click here and define this. Select this adaptive milling. This is a folder and tool D8 and workpiece. One more thing, workpiece I am going to show you. This is the part, and for blank I have used this part outline, right? So I'm using the same blank for this. Click here and OK. Here tool is defined. You cannot select any geometry. Geometry will select automatically. And here pattern, if it is open it will use jig, or if you want zigzag, so zigzag alternate cut direction it will use. For curvature radius 10%, right? Minimum curvature radius is 10%, right? For the corner roughing it will use this one. And the depth of cut is 90% of flute length. Here we are asking about flute length. If you want the tool dia, you can also select 200% of tool dia. So it depends upon you how you want. And the step over is 8% of tool dia. So it is 8. So according to the 8 mm, the step over will come only 8% of 8 mm. Whereas the depth will come 200% of 8, so 16 mm will be the depth. Let's see the results. So generate the tool path. See here, this is the tool path. Verify this. In adaptive milling, if you will see, the most of the portion of this tool is always in air. So the heat generated on the chip will come out and the tool will remain have long life. So here I am going to define this flute length 90% of tool length of the tool. Now generate. Let's see the difference. Here select this top face. So top face it is not selecting. So click here and generate. So tool will start, tool will create tool path on the top of the faces. See here on top face, here and here. All the top face tool path will be generated. Let's see the verification. Generate. Okay. Okay. Here we have this bottom up cutting. If you will enable it between the levels, when we have some taper surface or steep area, that time we can use this between cut level. If you will use this in the same condition, we will not find any difference. Let's see this. Let it generate. Now see, we don't have any extra cut on this vertical wall. So I am moving this to modeling, and here I am going to add some draft angle. So use this draft, and the stationary face is this. I want to draft this face, and OK. Again come to this manufacturing and double click here, and in the same condition just generate, and let's see the difference. Now you can see here we have 1 2 3 3 extra cut, 1 2 3 on the vertical wall, and the minimum depth of cut and the step up is given here. If you want to change, you can change number of slices like 5 3 4 5, and here I am adding this with 10 and generate. Because of height, it is not possible for this condition, no problem. And one more thing, let's see this 3D verification, and then we will select another example. Here you can see. Okay, okay. Now if you want to add more cut on the taper surface, so we will change this step up distance 1 mm and minimum cut 1 mm and generate. Now the intermediate label, the step between these two label will be increased. Now you can see. So hope you understand this, how to create this adaptive milling. Now I have a second example. For this example, I have this tool, and for workpiece, the part and the blank bounding block I have used. Now come to this and select this adaptive milling. Select tool, select geometry, and OK. Now I'm just keep all the parameter, just generate, and we will find some result. Right now I want to skip any area, so come to this geometry, and here in geometry we have this trim boundary. Now I want to trim this boundary, so select this curve, and with curve select the tangential curve and select this inner curve, and OK, and generate. So this area will be ignored. Rest of the portion will generate toolpath. Only in this area toolpath will not generate. This is the first scenario. But in second scenario, we can do one more thing. If you are defining the trim boundary, and here the trim side is inside. Now this time I want to trim outside, means the toolpath will not generate outside this boundary. If you will generate, you can see, right? If you want to check, just go and see the verification. So hope you understand this, how to create adaptive milling. Okay, and OK. Now if you want to generate the CNC program, so click here and go to post process, and from post process select the post. This is a 3-axis post, and OK. Tool number is missing. Manually, you can also edit the tool number. Say this. Okay. Hope you understand this.
Today we will see adaptive milling, and for adaptive milling I have one part and one more geometry. This is a geometry, right? So this is the blank. So I want to cut only this area, so I have created the blank for this area only. Now come to this, and here double click here, and my part is this one, and for blank I am just selecting this geometry. Okay, so if you want to create adaptive milling, so it is not compulsory to create blank for complete body. You can select or you can create any specific geometry for selected area. Now click here, and I want this adaptive milling, and here in adaptive I am using this, and my tool is this one, and this is a workpiece, and you want finish, rough or semi finish, whatever you want you can select. Right now the range is automatically, so it will automatically detect the material height, so no need to specify. Step over is 8% of tool, depth per cut is 95% of flute length, and the flute length is this one, it is 50. For top face it will create tool path. Intermediate I have not selecting right now, and generate. Without selecting the cutting area, toolpath will generate only for the blank area. So I have this blank area. Now the toolpath is generated. Although I have only this material, and it is created this toolpath for this complete height. Let's see this. So I can also define, right now it is unnecessary. So the range is automatically, I am going to change to specify, and my bottom object is this point, and generate this again. Say this. Okay, so toolpath will generate for selected area. Now if I want intermediate level, so create intermediate level. If it will find any taper face, so we can use this option also, and the step up and minimum cut depth is given with respect to flute length. Now see, so hope you understand this. Thank you for watching, and I will share this part.